Unit 1, Lesson 1. Oscillatory motion. In this lesson, we will study many subjects related to the periodic motion and oscillatory motion, such as examples for oscillatory motion, live application for oscillatory motion, graphical representation of oscillatory motion, amplitude, complete oscillation, and periodic time, frequency. Examples for oscillatory motion. Number 1. The motion of swing is an example for oscillatory motion as it goes forward and backwards around its rest point. Number 2. Stretching a string. Number 3. Tuning fork. Number 4. The clock pendulum is also an example for oscillatory motion, where its motion is repeated through equal intervals of time. Note: the oscillatory motion is one of the types of periodic motion. The velocity of oscillatory body, or pendulum, reaches its maximum value when it passes the point of rest A, and it decreases gradually as the body moves away. Live applications for oscillatory motion. The microwave oven. The waves of this oven make water molecules inside the cooked food vibrate. Note: the pots to be used inside the microwave oven should be made of pottery, ceramics, or glass, because metal pots reflect microwaves back to the source. Graphical representation of oscillatory motion. The spring is an example for oscillatory motion. If you fix a pencil in the load at the end of this spring and move a paper sheet near the pen during the oscillation of the spring, you will see a graph representing the oscillatory motion. Amplitude. The pendulum in front of you moves from rest point A to the left B and to the right C. This motion can be represented in the opposite graph. Amplitude. Amplitude is the maximum displacement achieved by an oscillating body away from its point of rest. The amplitude is measured in meter. So, the distances AC and AB represent the amplitude of this pendulum, and they are equal. So AC equals AB. Complete oscillation. This pendulum makes a complete vibration when it moves from B to C, then to B, as it appears in front of you. Note: each complete oscillation consists of 4 amplitudes, BA, AC, CA, and AB. Periodic time. Periodic time, which is represented by T. Periodic time is the time needed by an oscillating body to make complete oscillation. Periodic time T equals time, seconds, over number of complete oscillation. Exercise number 1. In the opposite figure, calculate the periodic time. Solution: T equals 9/3 equals 3 seconds. Exercise number 2. In the opposite figure, calculate the periodic time. Solution: complete oscillation equals 4 amplitudes. Time of complete oscillation equals 4 by time of amplitude equals 4 by 0.5 equals 2 seconds. Frequency. Frequency is the number of a complete oscillation done by an oscillating body in 1 second. Frequency equals number of complete oscillations over time, seconds, equals 1 over periodic time. Exercise. If a pendulum makes 20 complete oscillations in 5 seconds, calculate: number 1, the periodic time; number 2, the frequency. Solution: number 1, periodic time equals time over number of complete oscillations equals 5/20